All right, it is Tuesday, December 8th, 2020, Chemistry CP, period 6. We're trying to create random examples of ionic bonds. The two elements that were named were potassium, which always has one valence electron, and phosphorus, which has 5 valence electrons. The question is, how can we have them each become satisfied, potassium giving away 1 electron, while phosphorus gains 3 electrons? The answer is we're going to need more than 1 potassium to do this. In fact, if I draw the phosphorus, maybe like this, 1, 2, 3, 4, 5, then you could imagine if I have a phosphorus up here, another one down, why am I writing the H? Another one down here, one over here. Now I can make this work. Each phosphorus gives its electron, I'm sorry, I said phosphorus. Each potassium is K, phosphorus is P. Each potassium gives its 1 valence electron to phosphorus, which wants to gain 3 electrons. And this is the only arrangement that works for both elements, meaning I'm never going to have 2 potassiums with 1 phosphorus. I'm never going to have 2 phosphorus with 1 potassium. The formula that we get out of this is 3 potassiums for every phosphorus. And we would name this thing potassium phosphide. Potassium phosphide is always 3 potassiums to every phosphorus. Okay, maybe we'll try another example. Also from this list. Let's see. James, can you type into the chat a choice of an anion? Oops, I'm sorry, a cation. I've always been doing the positive one first. So pick any cation from this list and type its chemical symbol into the chat. Okay. And the choice is calcium. Calcium on the periodic table is always an alkaline earth metal, so it's always going to have 2 valence electrons. Our next volunteer is going to type into the chat any choice for an anion. Shreya. Okay, nitrogen. On the periodic table, nitrogen is always going to be a -3 anion. It's always going to want to gain 3 electrons. So this is going to be similar to the story with the phosphorus and the potassium, nitrogen has 1, 2, 3, 4, 5 valence electrons. And no, I don't know of any particular rule about where you draw the valence electrons. You could draw them more spread out than I did. How do we make both elements happy? Calcium will only combine with nitrogen if it can give up 2 electrons. Nitrogen will only combine with calcium if it can gain 3 electrons. Some of you may have already figured out what is going to happen. How shall I draw this? I don't know. One, two, three, four, 5. So here's a nitrogen with 5 valence electrons. Here is a calcium with 2 valence electrons. Okay, that will work. Nitrogen still needs 1 more valence electron. Here is a second calcium. It gives a valence electron to this nitrogen, but now it needs to get rid of the second electron. It will give that to another nitrogen. So here is a nitrogen with 5 valence electrons, and this calcium is going to give one to that nitrogen. Now this nitrogen has 6 valence electrons. Well, let's bring in another calcium with its 2 valence electrons. One goes here, one goes there, and there's probably a much neater way of drawing this than what I did. But now count up how many calciums you see and how many nitrogens you see, and notice that all of these atoms are finally happy. Each of the calciums got rid of 2 electrons. Each of the nitrogens gained 3 electrons. So the formula is going to be 1, 2, 3 calciums for every 2 nitrogens. And the name of this ionic bond is calcium nitride. Calcium nitride.